Alright, so today I'll be showing you guys how to solve this simple recursion problem in under 5 minutes. Given a non-negative integer and return the count of the occurrences of 7 as a digit. So for example, 717 will yield 2. And you can't use any loops, it's just recursion. So the first thing you want to do is you want to identify the base case. And then the base case is essentially a case that doesn't call back the function, and it's like the simplest thing you can do. It's just an if statement. The base case is a condition that stops the recursion. It returns a value without calling the function again. So in this case, the base case would be if the integer n is equal to 0, then we can just return 0, because if it's equal to 0, there's no chance it contains 7, so you can return 0. Okay, now that we've identified the base case, now we're going to want to identify the recursive case. So the recursive case is the part where the function calls itself. It's the part that gets the number closer to the base case, so we can end all the recursion and all the repeated calls of the function. So what we're going to do is if n mod 10 is equal to 7, then, so this if statement right here, n mod 10, it gets you the rightmost digit. So for example, for 126 mod 10 of that, you would get 6, because when you divide 126 by 10, the remainder will be 6. So you're getting the rightmost digit. So if the rightmost digit is 7, then we're going to call the function again. And we're going to take the number and divide it by 10. Actually, there should be a return here, and I'm also going to add a 1 to this, because since the rightmost digit is 7, we can increase our counter to how many times 7 has occurred in the number. So when you do the number divided by 10, what that does is it removes the rightmost digit. Since we've already checked it using this if statement, we can now remove it by dividing it by 10. So if you did 126 divided by 10, you'd get 12.6. And in Java, since it's an integer, it will just truncate, get rid of the decimal, so you'll get 12. Now for our else statement, what we'll do is just do else, and we'll copy this return statement, except we won't include a 1 this time, because this time in this scenario the rightmost digit is not a 7, so you would not add anything and you would just rerun and remove the rightmost digit. So let's run this and see if it works. As you can see, I got all the test cases correct, so this code works. Just a quick summary of what we did. First, we identified the base case, which is the case that stops the recursion. So in this case, it was if the number is equal to 0. If it's 0, there's no chance it contains the number 7, so we can already return 0 because there will be no 7 in that integer. And the recursive case is we're taking the rightmost digit every time and we're checking if it's equivalent to 7. If it is, then we're going to return 1, adding 1 to our count, and we're going to run this function again. This time we're getting rid of the rightmost digit, so we can just look at everything else. And if the rightmost digit is not 7, then we're just going to run the function again and not add 1 this time, because we did not find a 7 at that place.